Petum, who works at the university at the finest city on earth, is going to be presenting on mitmproxy, the use and abuse of hackable SSL-capable man-in-the-middle proxy. He has spent 20 years in the Unix and Linux shell, and I have good reason to believe that the user interface hasn't changed. He's been a sysadmin, a systems architect, and a security red shirt. That does not mean that he dies on Star Trek. He has worked in many different companies in the UK and New Zealand, from small startups that did not make him rich to large corporations that made themselves rich. He is currently working at the Information Security Office at the University of Otago, trying to separate good data from bad data. His business cards have a PGP key fingerprint on them, just in case. Please give a very warm welcome to Linux Conference Australia 2012, Jim Cheetham.
Right, first one, can you hear me? A low mutter, okay, that's good. Right, so I've come to talk about man-in-the-middle proxy that will help you to hack SSL-based traffic. It also helps you to hack a bunch of other things as well. If my projector thing works, there we go. So the things we're just going to cover here give you an idea of where we're going with the talk. We'll just hit a little bit of metadata at the front. I'll address what the bit of software is. We'll look into why it's a useful thing to have, which isn't automatically obvious to everybody. A quick bump through how do we use it. We'll do a couple of demos there with a bit of luck, technology willing. It all seems to be working well today. And a quick push on to what else it's been used for, what else it can do. So the metadata basically is a short recap of the introduction. That's me, Jim Cheetham from the University of Otago. Bit of feedback from somewhere. Background is basically Unix, internet. If I walk into a problem, I don't know what's going on from first principles, I'll start with strace. I'll start with Wireshark. That's the direction I like to work. So, mitmproxy. The description from the author of the project, which is not myself, is that we have an SSL-capable man-in-the-middle proxy. Normally when you hear the words man-in-the-middle, you hear the word attack. And that's deliberately missing from here. It's an interactive bit of software, so you can watch the flows of data going through it. You can also stop any of the requests or responses, edit them, send them on their way. It's nice and extensible. It's all written in Python, so you can drop off into any specialist Python module you want to write. Say, for example, the modification you want to make to the data is something you can't type in by hand or run through an editor, then you just slap it through a bit of Python. We'll talk about a couple of examples of that later on. It's very good at replaying requests or replaying responses. This is something which is, you can turn it into a general purpose tool now. Once you've recorded the conversation flow and modified it, optionally, you can just sit back and replay it in both directions. That means you can use mitmproxy to be the basis of a testing tool. You can sit there and creatively alter your requests or creatively alter the responses depending on which side of the conversation you're interested in breaking. It's also very good, when you ask it, of hanging on to any cookies or any authentication details that it's seen. This means that you can do something like run an interactive login through the proxy, go through all your login details using certificates, using two-factor authentication, using whatever you like, tell the proxy to remember all of that stuff, and then switch over to another tool like, I don't know, wget or something, which is incapable of using all your authentication. It'll replay the cookies, it'll replay the auth data when requested, and you've got a very high chance of getting this to work. And of course it's programmable, it's not just a tool which sits there which you can invoke Python with. It's a Python library, so you can stuff it into your own code directly. Very low requirements. Francois is trying to convince me to package that for Debian. It only requires one extra library, which is a pretty common one. So, yeah, I may actually take that challenge. You heard it here first, mate. Console goodness. None of this Windows, Java, GUI stuff. It's there, it's real. Sorry about the resolution on that one. One of those windows is basically VI, editing your body. It takes whatever your environment's choice is. If it can do Emacs, I believe it should be fine with that. One of the questions that's always asked when you come up with a new project is, what a great idea. What's the code look like? How mature is it? Sort of questions that you'd ask about convergence, for example, if you're interested in all of the SSL work that's going on. Convergence comes out as a very, very early lump of software. It's a fantastic idea. He's got a full implementation. Try and find the documentation for it. Read the code. Try and find out the use cases. Read the code. How good is the code when you read it? Well, it's a bit scary. It does actually work. So you want to address that sort of question. mitmproxy is relatively young. So version 0.2 was the first one, I think, to hit GitHub. So as far as the world's concerned, that's the first version. The current version 0.6 has been hanging around for a few months now. It is GPL v3'd, obviously with the SSL exception, because we want to use OpenSSL with this thing. That's just to make sure you realize it's under a good license. I think most of the code that Aldo writes is BSD'd, but he's chosen GPL for this change. So Mr. Cortese, currently living in Dunedin, is a pretty big, well-known professional security guy. He's got a couple of companies, which I'm not going to advertise at this stage because you'll find them off his website and talking about the project. But he's got a very wide range in the business, so he's got lots and lots of different motivators for writing this bit of software and lots of different capabilities he wanted it to have based on the fact that the other tools just don't quite fit what it is he's trying to do. I can hit about half of those in a reasonable level of confidence, and I can hand wave and talk about the others, but he seems to get paid for them more than I do. That's fine. And he's really, really fond of the Hilbert curve. So he's been using that for an awful lot of visualizations recently, including things like locating the encryption keys inside a bit of software. So you get a binary, and you wonder, where's the encryption key? So you go, quick calculation through looking for entropy, slap it all out on the Hilbert curve, end up with a couple of graphs that say, there's a pink block just there. That's the only pink block in the whole thing. I bet that's where the key is. Really makes it quick as do reverse engineering. And I'm pretty sure XKCD did their Hilbert curve map of the internet address space before he started playing. He doesn't really admit that. He thinks he did his first, but he can't prove it. So we'll just run through a few of the foundational definitions and conversations to explain how this works. Lots of people, I found more people at LCA when I talked to them when I came here were interested in the topic without knowing in great detail how everything worked first. And also there's a bunch of people here who know everything about the topic and are interested in the tool that will do it. So bear with me while I go through some of the foundational stuff. And it is a little bit simplified. First of all, HTTPS consists fundamentally of two parts: the transport layer security negotiation. When that's finished, you end up with ordinary HTTP running after that. There's nothing special about the requests that go between the browser and the server when you're running under HTTPS. The only thing that's special is the conversation that happens at the beginning to get the connection set up. And fundamentally, I have to do this laser pointer thing, but it's not bright enough to shine on the screen there. And hopefully that's legible. Let's try. See if we can. Oh, that's good. A bit ugly, sorry about that. We start off with the browser sending a client hello message off to the server, which is saying, I would like to talk to you under TLS, which everybody calls SSL, and it's not necessarily incorrect. And I do switch from one to the other myself occasionally, so I try very hard to say TLS all the time, but never mind. The server sends back a hello message, which includes a whole bunch of data about what capabilities the server has got and its authentication information. The client thinks, yep, that's fine, sends back the other half of the connection setup information that's needed, and then the server says, yep, we're finished, I agree with you, we can talk securely now, send me a normal request. And then after that point, you get quite straightforward HTTP request response, request response. The server hello is, that one there just sort of pops a little bit more detail about what happens when the server says hello. The fundamental thing we're interested in from the perspective of mitmproxy is that the server will hand over the certificate, the server certificate, and the intermediate chains and stuff to identify itself and to provide information about who's assured it, authenticated it, trusted it, which certificate authority has signed it. Is it a self-signed certificate? All the things you need to help to figure out whether you're going to automatically trust the site that you're talking to. Obviously, standard users say yes to everything, and it doesn't really matter what the contents of the certificate are, but we try really hard to stop that from happening. There's lots of places where it makes sense to use your own certificates, but if you train your users to start ticking dialog boxes, then as far as us security people are concerned, you've trained them to give them your credit card number. So send the certificate across. Hello done is not a particularly interesting part of the conversation. Once the browser receives the certificate and potentially a certificate chain with more than one in it, it goes off and does its own checks to find out whether it thinks that those are interesting and correct or not, including quite possibly a call out across the internet to a certificate authority online service to say, is the certificate still valid or has it been revoked? Now, again, we'll look at that in a little bit more detail later on. It doesn't really need to spend too much time on it. So we'll take the TLS phase, and this time we'll stick mitmproxy in the middle. Now, mitmproxy is an explicit proxy. So you go into your network connection setup and you say, proxy all HTTP, all HTTPS into this thing. It's not going to be sneaking in and trying to attack you because we're not interested in that. It's for diagnosis, not for attacking people. So fundamentally, the browser will send the client hello, destined for the end website, but it'll send it to mitmproxy. It's the same thing that happens when you're talking to any sort of proxy that's out there, although most of them just pass your TLS messages straight through and don't even bother looking at them because there's nothing that they can do practically to them. So mitmproxy sends out a hello to the website. It's its own hello message. Probably it's identical to the one that you sent. There's no real reason to change it, but it's capable of changing if it wants to. The website server says hello to the proxy. The proxy goes off and negotiates the rest of the connection. The browser at this stage is still sat there waiting for something to happen. Part of the server hello from the website that comes back to the proxy, of course, is the certificate of the site. Once the browser gets hold of that certificate, the only person that can communicate with it now is the person who's got the private key hanging at the back of that, which is the server. We don't have that, and we never will. So what we have to do here is modify the certificate. Well, frankly, replace it, to be quite honest. So we get a new certificate in there, and then we can do server hello back to the original browser, but it's got our certificate inside it this time. The browser then tries to validate our certificate. That's obviously not necessarily that easy. And then, of course, after we've got TLS set up, or, in fact, if we weren't doing any TLS at all and we were just straight HTTP, all of the browser's HTTP requests come to our proxy. We'll pick them up and send them to the website after we've modified them if we feel like it. When the website sends the response, we'll modify it if we want to, and then send it back to the browser. Just as a quick foundational here on what the certificate authority is sort of supposed to be doing. On your server up there, you generate a server key. That one's generated by you. That's private data. I end up calling it a private key quite a lot, and it's sort of not really, but it's a private lump of data for you. That is just a big lump of random data, of course. When you want to get this known to the outside world, have some way of people understanding that it is the correct piece of data for setting up the connection, we create a certificate signing request, and in there we stick the domain name of the site that we're supporting. Anything else like that we've got, organization, all those sorts of things. We've got to prove that we've got some reason to own the domain name. And you get your CSR, and you have to go and log into certificate authority so they can prove that it's really you. Send it to them. They'll do validation. They do different levels of validation depending on how much you're going to pay them. So somebody like Startcom will say, well, we've got your email address here, have a certificate. That's fine. Oh yes, the next level up we say, oh, you say you want it for a particular domain name, we'll send email to something in that domain Yeah, that's fine. That's not a very expensive check. And you go all the way up to the extended validation checks, which will go through and say, are you really the right company? Have you got the correct address? Have we got an agreement with you? Are you the person that's authorized to send these requests? Have you paid us enough money recently? Fundamentally, that's what it comes down to, of course, because there's no real definition of what a certificate authority is saying. Eventually, they send you back a certificate that's got their name at one end of it and their signature, and it's got your domain data in it. When the browser gets hold of the certificate as it's setting up the connection and tries to do a little bit of validation, the first thing it checks at the top, once it's got the certificate data, it checks the common name or the subject alternate name fields and basically says, does the certificate match the URL that I thought I was talking to? If it doesn't, we've got a problem. You get a little dialog box, click accept, just keep going, everybody does. And then we drop down and say, great, it's got the right host name on it. Which CA signed for this one? Let's have a look on disk, on the list of CAs that we've got on disk. Who gave us that list? Your operating system. Debian gave it to you. Or Microsoft or Apple gave it to you. Or Oracle gave it to you if it's in Java. Although they're all different lists. And of course you can add your own in there. Because this check's being carried out by the browser, it will also accept any certificate authority that it's previously asked you about and you've clicked the button to. That doesn't hit the disk, it just stays in session. And intermediate CA is what the thing says that fell off to the right-hand side. Sometimes you get a whole chain of trust inside the certificate, lots and lots of different people are mentioned. We go through and we check all the way back. As long as the one at the end is trusted, we're fine. And the last check, which is becoming, luckily, increasingly common these days, is to say, great, I've got the certificate, that's all fine. What if it's been revoked? What if the owner has lost their original key, gone out of business, just wanted to change the name? Let's go and do an online check for it. And that's a check which only ever returns no as a positive answer. So if the check doesn't happen, if the network blocks it, the browser just goes, oh, well, I tried. We'll trust it anyway. Fundamentally, the details that are in a certificate, and this will definitely scroll off to the right because it scrolls off to the right on mine, are, and I took this one from Linux.conf.au, HTTPS, Linux.conf.au, get the certificate, save it on disk. Use OpenSSL to have a quick look at it. It tells us it's got an issuer, and the issuer is blah, 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 Starfield, the certificate authority, based. I don't know why you're using that one, that's fine, they're all equivalent. It has a subject line, and that rolled off the right-hand side. So they've got organization O equals LCA under the stars.org.au. Turns out that's also the CN field, which is the interesting one, is LCA under the stars.org.au, despite the fact that I've gone to Linux.conf.au. So the naive check is the host name I went to, Linux.conf.au, does not match the subject line. But that's okay because we've got a secondary field now called DNS from the subject alternate name fields. And in there you can list a whole bunch of other names that this certificate applies to. The common one that pretty much all of the big CAs do is if you request a certificate for Linux.conf.au, they'll send you one for Linux.conf.au and www.linux.conf.au. If you request one with www in it, they tend to strip the www off and then give you one with both the dubs and the non-Ws. A little bit frustrating when we're constantly getting certs for internal machines that really, quite frankly, are not interested in talking to the web anyway, but doesn't cause any big problems. Frightens a lot of the Microsoft system administrators who really don't want to know what's inside SSL anyway. When man in the middle proxy has finished with it, the certificate looks a little bit different. The issuer is now mitmproxy. That's not a recognized CA anywhere. The subject line has been changed. There is no organization detail. All that's been stripped out. The only thing in it is the CN. In this case, the CN matched the host name that I called, which is linux.conf.au. The fact that the original certificate had a whole bunch of other data in it has basically been ignored. We're only using it for a very limited purpose. So the important thing here is if any of your end users ever see a certificate delivered by mitmproxy, it's going to look very different. And unless you've done something about it in advance, they're going to notice. This is good. because this is not an attack tool, this is a debug tool, and you should only really be using it where you expect to see it. If this was Moxie, he'd be trying to steal as many details as possible from the original cert and stuff them in and use Unicode so they're different but they look the same. So why is it useful to do all this stuff? Right? I can get in the middle of your secure connection to somebody, make it less secure, and change things. That's very interesting. Lots of people will hack just for the sake of it. And we've been able to do things like this for quite a long time with different tools. So why do we even want to do this task in the first place? Well, generally speaking, people have only really wanted to debug SSL connections when they're talking to an HTTPS server that they're in charge of, and they want to see what the request response was. They can read the Apache logs at the other end, and they can see the response that gets to the browser, but they're sort of cut out of the conversation in the middle on the wire. Now, we've got a bit of a shift in the balance of trust now, because I actually don't trust the client machine either. I certainly don't trust the conversations that are coming out of my machine and going across the network on my behalf when I'm running a large JavaScript application like Gmail, like anything that you get, like a lot of web pages you go to where you get several hundred K of JavaScript running in there, all making HTTPS calls out to dozens of different people on your behalf. What are they telling them? What data are they leaking? Now, I haven't written that, and I don't control the server. I'm at the client end. I could sit there and debug all the JavaScript and try and figure it out, but they minimize it, they make it difficult, they obfuscate it. We'll just sit there and watch the things going across the wire. We've also got all the software that comes from the app stores. I couldn't use the word app store. As far as I know, Apple is still fighting to claim that they own APP. But people are installing large blobs of software onto their mobile devices that are communicating over SSL. And there's just a big trust issue. What are they saying? What information are they shifting? There's an awful lot of personal data on my phone. What's going out? Using mitmproxy, you can have a look to see what's going out without having any rights to alter the software because it was signed and you can't alter it. And you do it without owning the server end of the tree. We've always owned the network in between, but with HTTPS, it's been very difficult to get in the way. So the existing tools that we have to spy on the network are a little bit inflexible. Wireshark does do unpacking gzip data, but only if you look at it per packet. If you do the wonderful TCP follow streams, all the gzip comes back again and you're left going, I can't read that. And there is a way of hacking it to work out. I've looked at a couple of websites, but frankly, it's just too much effort to get it to do it. From OWASP, the Secure Web Applications project, they've got Web Scarab, which is a very nice testing tool. I really don't like putting massive Java GUI clicky things on my PC to work with. Just something console-y is the way I want to think. And it's a bit old now. They're starting off with a new version. They're getting the next version in development. Quite frankly, it sort of looks pretty much the same as the old one in lots of ways. It's very Windows 95-y with the Java interface thing, but fully functional. It will do everything. It'll do a lot more as well because it will help you do automated testing and stuff. mitmproxy is just revealing the conversations. It's not really there as a education and development tool. All the stuff from OWASP has got a very, very good educational feel to it, help you developers to become a lot better. Well worth having a look at. Oh, this one probably should have been at the top next to the application store. I've got a phone, say an iPhone, to which I don't have very much access, and I've got applications I don't know what they're doing, like sending my high scores to Facebook and tweeting things for me. I can't exactly put TCP dump on it. Of course, with SSL, even if I could put TCP dump on it, it wouldn't do me any good. And there can be more and more machines that are difficult to put your diagnostic tools on, perhaps because they're locked down, but also perhaps because they're very, very embedded, low power, they don't really have much flexibility. So how do we use it? As I've mentioned a couple of times, it's not an attack tool, so you don't install it in your network and let it try and attack its way into your users, which is good. You explicitly configure it as a proxy. Now, that's best done sort of on a personal basis, just go and put your proxy in, but if you're an organization, you could, if you wanted to catch everything going through this thing, just go and publish it with your, whatever the autoconf thing is, which name escapes me. Then what you do is, as the mitmproxy starts up, it'll also generate a CA for itself. So you can just go and grab that file off the disk, slap it into your browser. Your browser will now just quite happily accept anything that mitmproxy tells it. The same way, of course, that your browser will quite happily accept anything that Komodo tell it, or DigiNotar, oh, not them anymore. It won't trust on it Archimed's second-hand car dealership and CA authority because Mozilla Foundation wouldn't allow that application to be added to their root CA for no good reason. Or if you are lucky enough to have a sub-CA somewhere and you've got root keys installed on all your users' machines by default, issue yourself a sub-CA from there and let it rip. None of your users will ever know because none of them will ever check. One or two of them will check and you'll tell them, sorry, it's policy, you've got no choice. Just keep those guys quiet. Or just keep clicking accept. It's the other way of doing it. Back at the university, we're just sticking a content inspection thing in so that we can go and stop malware coming in, and HR can stop people going to shopping sites like eBay. That's really good for policy for management. Technically speaking, we always had the question of a lot of these sites are now HTTPS sites, and we can sort of block an entire site, like we can limit your exposure to Facebook. They also want to limit Facebook without blocking it, but they would like to block Farmville completely on the grounds that it really has no place inside business hours. That's fine. We've got a system, it's a 40-gate I think we've gone for. They're quite happy to differentiate between the two. But if you're doing it all under HTTPS, we can't see exactly what it is you're doing inside that session, so we lose that ability to differentiate between two bits of traffic. So the question is, should we intercept HTTPS transactions coming from our users going to the outside world? The immediate problems you get there is, that's fine, you could, and basically you get a sub-CA set up and get root keys in, which doesn't suit our environment in the slightest. But then you've got to start whitelisting all the banks, because you really don't want to have any information related to a credit card floating across your network. As soon as you do that, if you've got a relationship with credit card processing in any way, one of the promises you've made is there won't be credit card numbers floating around anywhere. Well, if I go and stuff this proxy in the middle into HTTPS and start looking at things, and somebody logs into their bank, I will end up seeing their credit card details, and that puts you in a very, very difficult situation as an organization. You don't want to go anywhere near it. If you knew the name of every single banking website in the world, which would expose your credit card details, which would include someone like Amazon, who may well expose your credit card details as you're typing it in and setting it up, and you can guarantee never to hit any of those, you're wasting your time. You should just be saying no or changing the terms and conditions of employment and stuff like that. We've got a full Python API, so you can use this guy by just importing libmproxy and getting on with it. There's a standalone mitem dump, which works a little bit like a TCP dump. It just sits there and shows you what's going on. But you can stuff scripts into there and do replays and modifications on the fly as well. So there's all the ways we can use it. Sorry about the diversion into CAs and credit cards in the middle. Going to try a couple of demos. I'm not really sure about this. We're going to have to flick from window to window because there's an awful lot of screen space on there. So the first thing I wanted to try and do was to intercept a session going through. I set up a Wii account on Fastmail today. So if I pop a little copy of Opera over here, and Opera's set up. Oh, you can't quite see it from there. Oh dear. None of this stuff works very well on small screens. So at the bottom, I'm saying that I've enabled proxy servers. Basically, the reason I'm using Opera is because I didn't want to break my presentation that's running inside Firefox. I didn't really want to use Firefox. I wanted to use Chromium because I haven't got that much memory on here, but the presentation, CSS and stuff, just doesn't go for it. Mitem, thank you. Very small, very neat, very minimal. Nothing to see yet because there's been no traffic. One of the things to note as presenters is everybody gets nervous on stage when you're typing, your fingers go all over the place, so you've got to type slowly. watch, and then watch very carefully before we hit return. Oh, look at that. What's happened here? We just hit accept or approve to that one, don't we? I mean, that's what everybody does. Very first thing that happens, I went to fastmail.fm, and it's fastmail.fm certificate, so that's fine, yeah? Absolutely. That's because I haven't imported the mitmproxy CA into my browser, because it wouldn't be quite so interesting to look at. What's wrong with this certificate? Oh, it's signed by the unknown CA called mitmproxy. That's right. We can approve that. We're happy with it because we know what we're doing. Anybody else probably should be running away screaming at this stage. Oh, and www.fastmail.fm is also unknown. That's because when we looked at the reduced certificate which mitmproxy hands back, it only hands back the explicit name that the request was for. So where the original certificate from Fastmail has probably got .fastmail.fm, fastmail.fm, fastmail.fm.com or something, there have been loads of variations in there so they don't have to waste their time with hundreds of certificates at $100 a shot. But we're not doing that, so we're going to see multiple errors. Yeah, and there's a little bit of data beginning to show up in the back, but we haven't got it all yet because some of these requests are now blocking, waiting for user response. I don't know why we had that one come back. Yeah, we've hit approve a few times. Oh, look, there's Fastmail. Isn't that nice? And that's what's happening. Wow, sorry about that. The full screen got in the way. That's what's happening in the background. We've got mitmproxy telling us the very first request going through was UPnP host. Gosh, that's got nothing to do with it whatsoever. Then we see a request for HTTPS fastmail.fm, followed by a 200 response, 6-bit of HTML coming back, and then we see fav icon coming in on the next line, and then some more interesting stuff and more interesting stuff. So we'll take this one. We'll have a look at our request. Now, I'm very sorry about the black background. I know that white background works better for shell sessions and stuff and presentations, but I haven't found the right combination of term setting to try and convince this thing not to do color. We'll just live with it. It is 0.6, so I'll let him off. So we've got there, and it tells us the complete details of the request that was sent, so we know what we've said, we know what cookies we've sent to them as well now. And this is only HTTP at this stage, there's no great secret going on. And we can look at the response that came back from them, so we get to see the complete response headers there, and it was all gzip data, so it's just unpacked that for us, that's just a display option. So now what we've got back. And you can do the same for pretty much anything. What does the fav icon look like? Yes, there we go. It was an image X icon. Thank you very much. And you can go up and down and say, oh, there's some logos. They weren't that interesting. The GIF. Hey, Unisys. There's a GIF. So I used to work for them. Big Evil Corp. Other people here still do work for them. And I think they're all pretty, hopefully they're all pretty sorry about it. Right, let's understanding. Let's clear that. So that's the beginning of inspecting a session going in. It was all over HTTP, but perhaps we should try and do something over HTTPS just to make sure we know what's really going on. So Fastmail, I should be able to log in. I have got a YubiKey with me, but I haven't set it up. Wonder what my password is. Let's do a secure login so nobody can find out what it is. And now we are logged in. That's good. And there's the session from login time going on. That first one there, let's have a look. Well, it's very difficult to do this looking backwards. Let's have a quick squint. A post sounds good. That's pretty much what I did. That post was under HTTPS, as it says at the top. And we're currently looking at the response. Let's flip back to the request. Oh, look, you can see my password. Isn't that useful? So we've got all the stuff going through there. I'm going to speed up the demos because I'm being waved at for time, which is good. And the response that came back in this case, although it was a 200, was actually a whole bunch of redirects to get you onto the next page. Let's do a quick modification. In fact, let's do the modification off of mit-dump instead. Dump minus es. You'll see this bit of code in a minute. Right, mit-dump doesn't show you anything, but what it says is basically it's going to filter all of the requests through that little bit of Python, which I'll show you in a second. Hope this works. All right, what do we know about Microsoft? Google? Oh, Linux.conf.au. That's very strange. How do we achieve that? I was going to stop and block, but basically that's how we've done it. Just speeding up a wee bit. The very short script called no-google-ms.py basically says, define the request, it's got a context and a flow, pick up the flow host. Does it match something that's got Google in it? Yes. Okay, pick up the path. Was it a search request? Actually, I didn't refresh it when I changed it to a /search because when you're doing the query off the little thing at the side, it doesn't use the button G option. That's fine. Okay. In that case, in the request path, substitute, because it's basically a get, the word Microsoft is in the get request, substitute out the word Microsoft, stick Linux.conf.au in, go for it. Hence, the browser saw Linux.conf.au coming back as its response. Do a wee bit of client replay, if you like. Actually, I've only got 5 minutes, so I'll leave that out. I can describe it in words. What I've done here is sitting at the hotel, the ski lodge, before I came here. You had to log into their little interface. You know, you go and request a web page, and it pops up and says, "Which secret bit of data have you got for us?" You've got 3 hours of internet. So you run mit-dump with -w, which is, I'm just going to do the login thing, and you dump all of this flow down to a file on disk. Now, it's a big JSON thing. So let's go then, after we've got it and we've logged in, we've got the next page, take that file, put it back in mitmproxy, which is a little bit more interactive, whiz up and down the actual responses and requests, which I probably ought to do just for a random one. Let's go. Show you a quick edit. Refresh that page because I really don't care. Did we get something? Yeah. I haven't stopped any of these, but I could. So there's the response. Oh, I didn't unzip it. That's editing the body of the response, so I need to decode it. Sorry you can't quite see the very bottom of this thing, but there's a little bit of dialogue going on. And throw the response body into VI and get on with it. Change whatever you like interactively. Then you can return that to the client. So we pop it into mitmproxy, we go through, we edit the session file. In fact, basically all we're doing is getting rid of all the CSS calls and all the stuff that we don't need, and we're getting rid of the eventual website. What we end up with is basically just a post to a very invalid 1.1.1.1 with a username and password. It's on my bit of paper. So you do that, leave the proxy running, do your requests, drop out the proxy, and then you can do a log out and play it through mitmproxy as well. Although, quite frankly, don't forget you've got other tools on your machine that are just as useful, and the log out thing just did a quick post. So I'm being told time's up, so I won't show you the upside down to net, but it's exactly the same thing. If it comes in and says content type was an image, run it through ImageMagick Convert, pop it back into the stream, and everything goes upside down quite nicely. You could implement convergence in this thing if you wanted to, because you know what the certificate conversation is going to be, because it's only supported under Firefox. There's a thing called Netograph, which you ought to have a look at. Netograph is using this engine at the back end to go off and capture every single request that's made by your interactive browser. When it's finished, it has a quick look through the disk and says, you've got this many HTML cookies hanging around, you've got this many Flash cookies hanging around, you've got this many something else is hanging around. All these calls are made to all these other organizations that you didn't know about, and tells you how dangerous and complicated the eventual website is, and whatever else you want to use it for. Okay, there you go. Quick run through. Hope you enjoyed it.
Thank you very much, Jim. We do have some time for some questions. If you could make your way down the front if you want to ask a question. I've got one hand up there. Any others? Okay, I'll just pass it down to the first person.
Hi.
Hey,
Do you know if it is possible in browser JavaScript to detect the parameters? Could a web page detect that it's using a questionable cert?
I don't know if JavaScript can reach out to the browser's knowledge of the certificate. I don't think it can.
If it could, I'm thinking about a website that really doesn't want to be hijacked,
Google.
but you could just modify the JavaScript as it was coming through.
So Gmail was the target of the Diginotar attacks, if I remember correctly, and so that issued a fraudulent certificate for gmail.com and variations. The only people in the wild that noticed that it had changed were the ones who were running Chrome. Chrome knew that the intermediate CA for Gmail had to be the Google CA. Didn't care about the fact it was GoDaddy, I think, that signed it. Could have been anybody.
It's hard-coded into Chrome.
It's hard-coded in the software to say the intermediate certificate must be the Google CA. That's the only one that noticed the attack.
My bank wants me to download something called Rapport, which I think does a similar thing.
Probably a proxy, though, isn't it?
I think it just screens all the certs that come back for bank URLs and makes sure that they're the
Right.
right.
As a plug-in to Firefox and so forth, you can definitely do it at that level. If you could do it inside the JavaScript, I could edit the JavaScript as it arrived. So, yeah.
Further questions?
Kind of as a follow-up to that, do you know of any ways that, for instance, an application rather than a browser, because a lot of apps now just use HTTPS, are able to use something like the SSL library to do what was just mentioned, that Chrome does, kind of pin your application to a particular certificate or set of root certificates to say that if it's not one of these small set of certificates,
Yeah.
it's not allowed?
Yeah, if you're going to do the certificate negotiation yourself as an application, you can do anything you like with the data that comes through. Is that what you meant?
I just meant for instance, the common libraries like OpenSSL. If your app uses that, do you know if that's part of the functionality right now, or is that something that would need to
I'm
be
not
added?
aware of OpenSSL doing its validation by being told what's valid first and then returning a response. It can give you the full details of the certs that it's seen so that you can do that in your application, but I'm pretty sure it doesn't do it itself.
You can specify a CA path, and you can only have the certificates you trust in that.
Right, so the comment there was, with OpenSSL, you can specify the CA path to be one of your directories that's only got the one or two CAs in it. So if somebody went off and got themselves a Komodo cert, it wouldn't be in your private CA directory, therefore it could never have been valid. Okay, thanks.
Have you had any negative feedback from any major browser vendor? Or do you think it could be a possibility that any browser vendor would try and put countermeasures against this kind of an intercept direct into the browser? And what do you think would be possible?
SSL sniff's been around for years, which is an attack to do the same thing, to divert where you're going to. No, the browser manufacturers, as a general rule, don't seem to care. They're just making HTTPS requests to the spec. Your operating system is the one that's responsible for choosing who the CAs are. The user is responsible for clicking approve and never show me this dialog box again. So no, I haven't seen them care very much. Although Mozilla do care a little bit about the list of CAs that they bring in with their software. They don't seem to care enough about the entire security dialogue with people because it presents things in stupid ways. We've taught everybody to have a little green key on the request. It tells you that what the page that you received was secure. It doesn't tell you where the form is going that you've just put your username and password into. So the whole user interface dialogue is completely screwed for SSL. The browsers are stuck. They haven't fixed that. But equally, they haven't fixed any sort of question about the trust issue of the CAs themselves. So they don't care about that. They don't care about a debug tool. Oh, there's upside down to that. You probably noticed it. That's just that little image flip.
Any other questions? Yes.
So just one last quick one. I know the app's written in Python, but is there any chance it would be possible for it to use any other language? Like, is it possible, is it able to kind of call some, like a shell script or something to do the same kind of processing?
Yes, yes, I did. I'm calling ImageMagick convert as a system call just here to get that done.
That's not Python doing that, just going out to shell or something.
Correct. It's only Python that's picking up the request and detecting that it's an image. In fact, if I just flip back, we didn't spend long talking about it because we ran out of... There we go. So effectively, all I'm doing is subprocess popen to convert.
Yeah, sorry, I missed that.
No, because I didn't have time to stop and look at it. That's fine.
Well, we actually do have a couple more minutes, so if you want to run that.
Wow. I am running upside down to net at the moment, to be quite honest.
Because that's quite that is quite a fun one.
Where would you like to go? They'll slow my poor little laptop down. Amazon. I was thinking Flickr.
Google Images.
And of course, that's probably not an HTTP. Oh, sorry. My mistake. That's probably not a very
Search for Linux.
HTTPS, actually. There we go. Ballarat over the stars.
There we go. After everything's upside down here.
Yeah, I've got another upside down to net script which was attempting to use the upside down text converter that flips it all into Unicode and pops it back. But I've never used Beautiful Soup before, and trying to get them back in just proved too difficult for the time I had available. But fundamentally, the script was doing the same thing. If the request coming back was text HTML, take your HTML, give it a Beautiful Soup, grab out all the text objects, flip them upside down with that Unicode transform, stuff them back into the HTML, send it back. I think the problem I had was I had to decode the data because it was gzipped on the way in, which is fine, and I was encoding it back to gzip on the way up, but it may well have stripped out a header and I hadn't actually bothered looking. So, but fundamentally, that's all you'd have to do to really freak them out.
Okay, thank you very much, Jim Cheatham. Wonderful presentation. We also have a little something for you from Linux Conference Australia 2012. It's a gold-plated glass penguin. Thank you. We can now break for lunch.